Okay, so now that we've kind of looked at some of the nuances of a square root and the idea that we're always wanting to be technically talking about the principal square root under most circumstances, we learned that to simplify something, we need to take advantage of a square root. And that actually extends to even the fourth root. If I had a fourth root of x to the fourth, right, that would simplify to the absolute value of x as well. Or the sixth root of x to the sixth would be the absolute value of x. Because again, the idea, negative 2 to the fourth is the same thing as 2 to the fourth. These are both equal to 16. But since we're talking about a principal root, we always want to talk about the positive root of that. And so to make sure that that happens, we take advantage of the absolute value. So let's take a look at some situations where we simplify that. The first one, just kind of a nice, straightforward one. I'm just changing variables. So the square root of y squared, well, to handle everything positive and negatively, right, we're going to talk about that being the absolute value of y. And then, of course, once we know what y is, we can basically finish that off. So that one, again, just a straightforward one based off what we've already seen. Oops, excuse me. The next one, we have a multiplication. So we have a square root of 25 over x squared. So we can actually break this up in pieces. Again, the reason why will become clearer in a couple of examples or a couple of modules away from now. But we're basically talking about the idea of the power of a product. It's okay to take a product and break things up. But we know that the square root of 25, that's 5. And the square root of x squared, well, using this idea up here, it's that. Technically speaking, you could probably write it this way. That would be the real technical feature. So this basically, what underneath that is 5x being squared. You can really start to see that power of a product that I was just mentioning there. So if I take 5x and I square it, I get 25x squared. So using this rule, how do I simplify that? I slap absolute values around it. What's the absolute value of 5? We already know it's 5. So x, we don't know what that is yet, so I have to keep those absolute values there. So you can kind of really see that. So there's the whole rounded version there. So that would be a technical answer. That's probably going to be the one you see in the back of the book. And here's the reason why. Let me write that a little bigger, because we're talking about 5x being squared. C looks very similar, but we're not talking about a product anymore. We're talking about a difference. And so hopefully you guys have learned by now. A lot of you guys have been making that mistake, and I've been telling you there is no power of a difference rule, right? There's the power of a product, but not power of a difference. So this, we can't break it up like we're doing over here. But what I can do, right, is my power and my index are the same. So I basically have this rule. So this turns into the absolute value of 5 minus x. And of course, unlike here where we can break it up into pieces, here this 5 and this minus x all go together. So that is our final answer. There's nothing I can do with that because there is no power of a difference rule like there is a power of a product. So here we can break it up, here we can't. So that's our final answer. D looks a little odd because we have 4x squared plus 12x plus 9, and you have to make note of all the plus signs. Again, there is a power of a product, not a power of a difference. Same things for a addition. So you can't take this radical and start taking the square root of each individual piece. It all goes together because of those plus signs. So it doesn't look like we can do anything with that until we realize that 4x squared plus 12x plus 9, if you keep looking at that, that is one of our perfect square trinomials. So when I treat it like that, right, this is 2x plus 3 and 2x plus 3, otherwise known as 2x plus 3 squared. So this is actually the square root of 2x plus 3 squared. And now we have this simplification rule in play. My power matches the index, and so to make sure we have all our bases covered, we're going to slap an absolute value. And again, notice the nuances. Up here, we were able to break it up into pieces because we have a power of a product, right there. Here we have a power of a sum, and there is no rule for that, so you can't break that up. You got to treat that all together, which is why I'm leaving that alone. The square root of a to the 6th, Well, again, I'm trying to match my power and trying to match my index. So right now my index is 2 and my power is 6. So if we kind of think about this, a to the 6th, well, that's a to the 3rd power to the 2nd power, right? That would be our power of a power where we multiply. So I can rewrite this as the square root of a cubed squared. And now that I got it written there, right, my power matches the index, so we're going to throw absolute values around that. And again, this is a power, not a factor. So that's probably our final, not probably, it is our final answer there. So tell me what a is and I can finish it. But right now, that's the best I can do in terms of simplifying that. Here we have an index of 8 and a power of 8. So the powers match each other, and they also happen to be even. If we did this longhand, right, we would actually take the negative 3 to the 8th power and eventually end up with some number that is going to be positive. But if we just use the rule here, right, since it's an even index, we're going to take the absolute value of negative 3. And so the answer here would be positive 3. And then you can use your calculators here, right? If you took negative 3 and raised it to the 8th power, you're going to get a huge number. Take the 8th root of that, and you're going to be all the way back at 3. You're basically just going to reverse yourself. So just cut to the chase. The rule saying, it doesn't really matter what your power is, right? This will be the absolute value of it, especially if n is even. It works for square roots, 4th roots, 6th roots, any even roots, even 8s. Here we have a 4th root of 16, and it's times x plus 3 to the 4th. So there's actually two pieces here. The 4th root of 16, well, we know that to be 2, right? That's the principal one. And then what we have here is the 4th root of x plus 3 to the 4th. Well, that's that stuff up here. So that's the absolute value of x plus 3. And so we have a product, and we know products can be broken up. And we saw it here, and I'm using it here. But notice I am not breaking up the plus sign. I'm treating it all together. It's because of our exponential rules, as we'll slowly see. Looking at this, it looks like let me rewrite that because that's a little messy. So we're talking about the square root of negative 5a squared. So this whole thing is being squared. Well, my power matches the index. So by our little rule here, we're going to take the absolute value of negative 5a. And of course, since I'm multiplying here, right, we do know for a fact that the absolute value of negative 5, well, you can actually break it up like this. The absolute value of negative 5 is 5. And the absolute value of a, well, we don't know that yet because we don't know what a is. So you can already start seeing, and I think we saw it way back in chapter 4, there's a difference between taking powers of products and taking powers of sums and differences. And that's having a major role in how we actually simplify some of our expressions. So be very careful. This is only section 10.1. You're going to see a lot of this. So we'll get a lot of practice of that idea that yes, it's okay to break up products, not okay to do differences in squares. So let's keep moving forward. We'll just keep practicing and learning as we go.